Okay, Fast Track. In this video, you're going to apply the rules of trig that you learned in your last video. So let's start by solving example 1. So in triangle ABC, angle C is the right angle. So we're going to find cosine of A if little a is 3 times the square root of 13 and B equals 2. So the first thing I want you to do is draw your triangle. And let me show you how I want you to label your triangles. So notice that the problem said that angle C is the right angle. So this right here should be letter C. So let's put the A and the B over here. So notice that the uppercase A, B, and C, those represent the angles. Now the lowercase letters, those are the sides. So here is angle A. So the side right across from that is side A. The side right across angle B is side B. And the side across the angle C, or the 90-degree angle, is side C. So notice that the sides are denoted by lowercase letters. So now that we have our triangle labeled, let's go ahead and keep labeling it with the measurements. So they tell us that lowercase a is 3 times the square root of 13. So this right here is 3 square root of 13. They also said that side B is 2. So now let's answer the question. The question is asking us to find cosine of angle A. Now, in order to do cosine of angle A, we have to go back to SOHCAHTOA. And we're asked to find the cosine of angle A, therefore we're going to use CAH. So the cosine of angle A will be the adjacent over the hypotenuse. So the angle that we are using is angle A. So let's label our sides using angle A. So again, I'm keeping angle A in mind, so let's label our sides. The side right across from angle A is the opposite. The side right next to angle A is the adjacent. So notice that we are missing the hypotenuse. So the cosine of angle A, like I said earlier, is adjacent over hypotenuse. So let's fill in the blank. Well, notice that we don't have the hypotenuse, so we're going to have to find it. But since we have a right triangle, you know how to find it. So you're going to do Pythagorean theorem. So legs squared plus legs squared equals hypotenuse squared. So 3 squared is 4. Now let's go to our decimals calculator to type in 3 root 13 squared. And we get 117. So 4 plus 117 is 121. To solve for C, you take the square root of both sides, and C equals 11. So side C is 11. So now that you have your missing information, you're able to set up the ratio. So again, the adjacent is 2 units. The hypotenuse is 11. So the cosine of angle A is 2 over 11. So very similar to the lesson we did yesterday. Now I want you to try this one on your own. So pause the video, come back after you've tried it. In triangle ABC, angle C is the right angle. And I want you to find cotangent of angle A if side A is 5 units and side C is 13 units. Always start by drawing your right triangle. And again, the problem states that angle C is the right angle. So make sure you put letter C where the right angle is. And of course, let's put the A here and the B here. Remember, the angles are uppercase letters. So let's label our sides. It says that side A is 5. So remember, side A is right across from angle A. So this right here is 5. Side C, which is right across angle C, which is the hypotenuse, is 13 units long. And now let's answer the question. The problem states to find cotangent of angle A. So let's go back to SOHCAHTOA. So now remember, the cotangent is the reciprocal of tangent. So cotangent is adjacent over opposite. Now we are looking at angle A. So focus on angle A. Let's label the given. The side right across from angle A is the opposite. The side right across from the hypotenuse is the side right across from the 90-degree angles is the hypotenuse. So of course we're missing the adjacent. And you already know how you're going to find it. You're going to do Pythagorean theorem. A squared plus 5 squared equals 13 squared. A squared plus 25 equals 169. Subtract 25 from both sides. And square root of both sides. So A equals 12. So that's the adjacent side. So now that you have that, let's go ahead and set up our ratio. So the adjacent is 12 and the opposite is 5. It doesn't reduce. So the cotangent of angle A is 12 over 5. For example 2, in triangle ABC, angle C is the right angle, and I want you to find the sine of angle A if side A is 9 and side C is 3 root 10. So let's always start by drawing our triangle. You see how my triangles always come out perfect? So let's start with the right angle, which is letter C. Now let's label the measurements. Side A is 9. Side C is 3 root 10. And the question is asking for sine of A. So again, back to our friend SOHCAHTOA. We're trying to find the sine, so we're going to use SO. And of course, we're interested in opposite over hypotenuse. Now we're focusing on angle A. So I'm going to circle that. Now let's label the given. Right across from angle A is the opposite. Right across the 90-degree angle is the hypotenuse. So no need to do Pythagorean theorem on this one. We have both of our numbers. The opposite is 9. The hypotenuse is 3 root 10. Now, this problem does have an extra step though. You have to do what's called rationalization. So in other words, we have to rationalize this. And by that I mean we have to get rid of the square root of 10 from the denominator. So that's another thing that you guys have to memorize for this class. You cannot have square roots in the denominator. So to get rid of it, you rationalize it. So here's how you do that. Just multiply by the square root of 10 at the top and the bottom. Simplify and you are done. So the numerator, you get 9 times root 10. The denominator, you get 3 times the square root of 100. And of course, I did 10 times 10 and I got 100. So let's simplify even further. 9 divided by 3 is 3. Or how I like to do it, 3 goes into 9 3 times. Bring down the root 10. Now bring down the square root of 100. And of course, that's a perfect square. And the square root of 100 is 10. So remember, you cannot have a square root in the denominator. So you do what's called rationalizing. And you just do that by multiplying both numerator and denominator by square root of 10 in this problem. We'll practice that more in a minute. So go ahead and try this problem. So pause the video and come back once you've tried it. In triangle ABC, angle C is a right angle. Find cosine of angle A given the two measurements. Very first step, draw your triangle. Problem said that angle C is the right angle. So let's write down our measurements. Side C is 25 root 2. Side A is 25. And we are trying to find the cosine of angle A. So katoa, we're trying to find the cosine of angle A, so we're going to use ka. So you know that you're going to need the adjacent over the hypotenuse. Now remember, you're looking at angle A, so circle it and label your given. This right here is the opposite, and this is the hypotenuse. So of course you have to find the adjacent on this one. So Pythagorean theorem. So 25 squared, I believe, is 625, but let me make sure. 625. Mm, 25. So we should be able to do this without a calculator. Let me try. So we're going to distribute that squared to both of those. You get 25 squared times square root of 2 squared. So of course, you know that the square root cancels out with the squared, leaving you with 25 squared, which is 625 times 2, which is, let's check on the calculator, 1,250. So now subtract 625 from both sides. That leaves you with b squared equals 625. Take the square root of both sides, and b equals 25. So that's our adjacent. So let's set up our ratio. The adjacent is 25, and the hypotenuse is 25 root 2. So again, you cannot have a square root in the denominator, so you have to rationalize. But first, let's reduce this fraction a bit. 25 goes into 25 one time. So this reduces to 1 over root 2. So now let's rationalize. To rationalize, you multiply both numerator and denominator by root 2. And your numerator, 1 times the square root of 2 is square root of 2. The denominator, square root of 2 times square root of 2 is square root of 4. And of course, the denominator is square root of 4. It's a perfect square, so it's 2. So notice that we simplified it, we rationalized it, and our answer is square root of 2 all over 2. Okay, before we get to example 3 and 4, let's practice rationalizing even more. So example 1, to rationalize this, you multiply both numerator and denominator by square root of 5. And you simplify. So the numerator, 5 times root 5, you bring it down. The denominator, bring the 3 down. Square root of 5 times square root of 5 is square root of 25. So the only thing I can see that we can simplify here is the perfect square. 3 times square root of 25 is 5. And of course, let's just do it the long way first. At the denominator, 3 times 5 is 15. And of course, you can reduce. 5 goes into 15 3 times, making your answer square root of 5 over 3. And the easy way here is you could have done that from step 1 right here. 5 goes into 5 one time, leaving you with square root of 5 over 3. Okay, so I don't know if you guys have realized it already, but this right here, that step is kind of unnecessary, but I was just showing you so you can understand the math behind it. Every time you do square root of 5 times square root of 5, your answer is going to be 5, because these two multiply to give you 25, and the square root of 25 is 5. If you had square root of 4 times square root of 4, the answer would be 4. Here's why. 4 times 4 is 16, and the square root of 16 is 4. So one more just in case you didn't get it. Let's say you have square root of 7 times square root of 7. The answer would be 7. Here's the math behind it. 7 times 7 is 49, and the square root of 49 is 7. So you can start using that shortcut now that you know the math behind it. So example 2. Let's rationalize. So multiply numerator and denominator by square root of 3. Your numerator becomes 7 root 3. And if you do the shortcut, you know you should get 3 for the denominator. But let's not skip any steps for this problem. Square root of 3 times square root of 3 is square root of 9. And of course, that's a perfect square. And you get 3. 7 over 3 does not reduce. So that right there is our final answer. Now, example 3. Find the sine of theta if the cosine of theta is equal to 7 over 5. So pause the video real quick. Think about how you would solve this problem before I show you. Okay, now they gave us the cosine of theta, which is 7 over 25. So from using SOHCAHTOA, you know you're going to use CAH. So in other words, I gave you the adjacent over the hypotenuse. Now, so let's draw a triangle and let's label it. Now, the theta could go anywhere. So let's put the theta right here. Now, this is the angle that we're looking at. So the adjacent is this side here. And the hypotenuse is always across from the 90-degree angle. So that goes there. And the adjacent was 7 units long. Now, the question is asking for the sine of theta. And you already know that the sine of theta is opposite over hypotenuse. And of course, we're missing the opposite. So let's find it using Pythagorean theorem. (49 plus b squared equals 625). So 625 minus 49 is 576. Take the square root of both sides. And that's 24. So our opposite side is 24. So the sine of theta is equal to 24 over the hypotenuse, which is 25. The ratio doesn't reduce, so you are done right there. The final example, example 4. Find the cotangent of theta if the cosine of theta is equal to square root of 2 over 10. So again, I will pause the video, work it out, and then come back once you have your solution. We're going to start by writing SOHCAHTOA. We're given the cosine, so we're going to use, so they gave us the adjacent over the hypotenuse. Next thing I'm going to do is draw my triangle. And let me label the given sides. Let's put the theta up here this time. If that's the theta, this right here is the opposite. The hypotenuse is always across the 90-degree angle, and the adjacent is the side right next to the angle. And again, we were given the adjacent, which is square root of 2. We were given the hypotenuse, which is 10. Now the question is asking for cotangent of theta. And remember, cotangent is the reciprocal of tangent. So you got to flip that, and you're going to use the adjacent over the opposite. So the adjacent we have, but the opposite we do not. So let's find it using Pythagorean theorem. Lex squared plus lex squared equals hypotenuse squared. Square root of 2 squared, the square root and the square cancel out, leaving you with 2. 10 squared is 100. Subtract 2 from both sides. Take the square root of 98. And you get a decimal. It's not a perfect square, so let's leave it like that. So the opposite is root 98. So let's set up the ratio. The adjacent is square root of 2. The opposite is square root of 98. So notice that you have a square root of 98 at the denominator, so you have to rationalize. So one step further, and we're going to rationalize by multiplying both numerator and denominator by square root of 98. Now, if you use the shortcut for the denominator, square root of 98 times square root of 98, you're going to get 98. And the numerator, 98 times 2. Let me just put it in the calculator so I won't make a mistake. You get 196. So the square root of 196. Let me just make sure if it's a perfect square or not. And it is. Square root of 196 is 14. And of course, you can reduce this fraction. And I believe you can reduce it by 14. So the cotangent of theta is equal to 1 over 7. Let me make sure. Yep, 7. So your answer is 1 over 7. So pretty easy lesson. Make sure you remember that I'm available from Monday through Friday from 9 to 11 and 12 to 3. But go ahead and try this problem, pause the video, and come back to see if you got the correct answer. So I'm asking you to find secant of theta if the cosecant of theta is 5 over 3. So I'm going to write down SOHCAHTOA. And you have to memorize that cosecant is the reciprocal of sine. So you were given the hypotenuse over the opposite. So let's draw the triangle and label it. Oh, that was ugly. So let's put the theta down here today. So the hypotenuse is 5. The opposite is 3. And the question is asking for the secant of theta. So one more thing you have to memorize. The secant is the reciprocal of cosine. So the secant of theta will be the hypotenuse over the adjacent. Now, let's label our triangle. If this is the theta we're looking at, this right here is the opposite. This is the hypotenuse. So of course, we're going to have to find the adjacent. 3 squared plus b squared equals 5 squared. 9 plus b squared equals 25. Subtract 9 from both sides. Take the square root. You get 4. So now that we have all missing sides, the hypotenuse is 5. The adjacent is 4. So the secant of theta is 5 over 4. So make sure you like, comment, and subscribe.